Hello. Now we are going to look at tangents to curves. So to begin with, a tangent is a straight line that intersects a curve at only one point. So it crosses a curve at only one point. So it's a line. So if I'm asked for the equation of a tangent, I'm being asked for the equation of a line. So anytime I'm asked for the equation of a line, I'm going to open up my log tables and I'm going to write down the formula for the equation of a line. Y minus y1 is equal to m on x minus x1. Anytime I'm asked for the equation of any kind of line, I write that down. If I'm given a picture, I might use y equals mx plus c to help me solve the problem as well. So I could also be dealing with y equals mx plus c if I have a picture like I do here. So let's have a look at our question here. We're asked to find the equation of the tangent to the curve of our y is equal to our quadratic here at the point 1, 2. So I have that drawn in here. My black line here is my tangent to my curve. It's only touching the green curve at one point. And I want to know the equation of that black line. Well, if I go to my formula here and use my algebra method for getting the equation first, I would have to find a point on my line, and I would need to know the slope of my line. So in this case, I'm directly given the point on my line. I'm told that I'm interested in the point 1, 2 on my green curve. That's where I'm going to have my tangent. So that means that that point has to be on my tangent line. So I have my x1 and my y1, but I don't have the slope. So how would I get the slope of my tangent line? Well, the slope of the tangent to the curve is a phrase I know for the derivative. So the rate of change of the green curve, the slope of the green curve at a particular value of x at a particular point, is given by dy dx, is given by the derivative. So if I get the slope formula, if I get dy dx for my green curve, and then I say I'm interested in when x is 1, that's the x value I'm interested in, that's going to give me the slope that I want for my line. Now, if I have a picture, I can also do this visually. So if I have a graph like this, I should be able to read it. So what's the equation of this black line? Well, if I have a picture, I can use y equals mx plus c, and I can say that its y-intercept, c, is minus 3, and if I run across by 1, I rise all the way up. I rise 5 spaces. So rise of 5 over run of 1, so my slope would be 5 over 1. So I know from my picture that the equation of this line should end up being y is equal to 5 over 1 x minus 3. So let's see if that's what we get when we do this using our derivative and our algebraic method. So we're looking for this equation that we've just gotten from our picture. So I need to get dy dx of my curve. So I'm going to write down the equation of my curve. I'm going to get dy dx. I'm going to use the formula tables rule that I have for getting the derivative. If y is equal to x to the n, then dy dx is multiply by the power, multiply by n, and then subtract 1 away from n, subtract 1 away from the power. So multiply by the power, subtract 1 away from the power for everything involving an x. So dy dx, open up our bracket, so we have 4 on, multiply by the power, and subtract 1 away from the power. Multiply, open up another bracket. I have x by itself, means x to the 1, so I have multiply by the power, subtract 1 away from the power. And a constant, its derivative, is just 0, always. If it doesn't involve x, its derivative with respect to x is just 0. So I simplify this now. 2 minus 1 is just 1, so I end up with 4 by 2 is 8. X to the power of 1 minus 3 on x to the power of 1 minus 1, well, x to the power of 0 is what I'm going to get for that. And any number to the power of 0 is just 1. So that's just going to be times 1. So I end up with 8x minus 3. Now that's the formula for the equation of, that's the formula for the slope of that green curve at any value of x. Because it's a curve, we can see x is involved because the slope's always changing. But I want to know the slope when x is 1. So dy dx when x is equal to 1, well, I just sub x is 1 into my equation. 8 minus 3 is 5. Now that is the slope of my line. So I sub that into my formula. I now know the slope and I know my point. So I'm going to sub that in. Y minus 2 for my y1 is equal to 5 on x minus 1. And I tidy that up. Y minus 2 is equal to 5x minus 5, multiplying out my bracket. And to get it in the same form as I started out with here, I could rearrange that equation. Plus, plus 2 to both sides. So make left-hand side bigger by 2 and the right-hand side bigger by 2, and I would be left with y is equal to 5x minus 3, as I expected from my visual work. Now, where is the slope of our green curve here going to be equal to 3? So I've drawn in where this actually works out so we can see what we end up with. But what we're looking for is, when is the slope of the tangent line going to be equal to 3? So what we're looking for is the black line here should have a slope of 3. So run across by 1, rise by 3. So I can see from my picture that that's going to happen at 2 minus 1. The coordinates of my point there are 2 minus 1. So let's see how that comes out of doing the derivative and doing the algebra. So I have my y value here, and if I'm looking for the slope of a curve, I immediately think I want dy dx. So if I think of the slope of a curve, I'm going to think dy dx. That is how I get my slope. And for my curve, I know the slope's always changing, so I expect that this is going to involve x. So I'm going to work that down. So I have dy dx. I have my y just up here. So 2, open up my bracket, multiply by the power, subtract 1 from the power. Minus 5. I have x to the power of 1. So 1 times x to the 1 minus 1. And my constant just goes to 0. So the units number just goes to 0. And I end up with 4x to the 1 minus 5 on 1. So I end up with dy dx is equal to 4x minus 5. Now that's the equation for any, that's the slope for any value of x. Because our green curve, we always have a changing slope depending on our x value. We want to know, when would our slope be equal to 3? Well, if this is the slope function, our rate of change function, I want to know when that's equal to 3. Well, that's an equation I know how to solve, so I just rearrange it and find my value of x. So I work that down, and I get 4x is equal to 8. Divide both sides by 4. 4 divided by 4 is 1, and I want 1 of x. So 1 of x is equal to 2, as I expected. Now, if I'm asked for where something is, I need to give its coordinates, so I need to give its y value as well. So I need to go back to my curve, and I need to sub in that value of x and find my value of y. So I sub that in, and I work that down. I can put that into my calculator, and I will get out my answer of -1. So where does this happen? It happens when x is 2 and y is -1. That would be my answer. Now finally, what is the equation of the tangent to the curve this, so the green curve here, that is parallel to this given line? Well, if I think of the word parallel, I think the slopes are equal. So when is the slope of the tangent to the curve going to be the same as the slope of this line here? Well, to answer that, I need to know what the slope of that line is, so I need to rearrange it. So minus 4x plus y plus 5 is equal to 0. If I rewrite that in the form y equals mx plus c, I'll be able to read what the slope is. Otherwise, I'd have to find some points on this line and do lots of extra work. But I can just rearrange this in the form y equals mx plus c. So get y by itself, and I end up with 4x minus 5. Well, that means the slope must just be 4. So the slope, m, is just 4 over 1. So now what I'm looking for is the equation of a tangent that has to have a slope of 4, but I don't know the point on it. So I need to write down my y minus y1 is equal to m on x minus x1. And I know the slope this time, but I don't know the point. So how am I going to find the point? Well, I could find out when is the slope of this green curve 4, and then I'd use that to find the point I'm looking for, and then I'd have a point to sub into my equation. So I need dy dx of my curve, and I'm going to use that and find when dy dx is 4. So when I've used my power rule, I get that the derivative, my rate of change of my green curve, is going to be 6x minus 2. So where is that slope going to be equal to 4? And I solve that equation to find my value for x. I need to add 2 to both sides. 6x is going to be equal to 6. So x is going to be equal to 1. But I need to know an x and a y to sub into my equation. So I have to go back to my original curve and sub in x is 1. And I get that y is 2 when I've tidied that up. Well, now I know all the information I need. The slope is 4, and the point I need on my curve is going to be at 2, 1. So I know my slope, I know my point, so I can sub into my equation of my line formula and tidy it up to get my answer. So y minus 2 is equal to 4 on x minus 1. I just multiply all of that out and tidy up my equation. 4x minus 4. And often we'd be asked for our equations in standard form, so we'd rearrange everything to be equal to 0. So I'm going to minus y, add 2, minus y, and add 2. And the equation of my line would end up being 4x minus y minus 2 is equal to 0. And that is how we can get the equation of our tangent to our curve. So we can see how we can use the derivative to get the slopes of our curves, and then use the equation of the line formula to use those slopes and the points that we find to get the equations of our lines. And that is what we need to know for tangents to curves.